Good afternoon, everyone. Thanks for joining us today. My name is Chris Villamay. I'm a network architect on NetBrain's technical marketing team. And joined with me today is Chris Lopez, also from our technical marketing team, and he's going to run some pretty cool live demonstrations in our lab environment. So let's go ahead and get started. When it comes to applying an automation strategy for network operations, specific to this talk today for incident response and network problem investigation, IT problem investigation. So where do we start? So this is something that's going to look pretty familiar to everyone here. This series of interconnected systems within a common workflow. You have the detection of the problem, the alarms, the ticket created, all with the goal of getting someone to investigate and then, of course, to remediate, to fix the problem. This is what represents that mean time to repair, MTTR, that we desire always to reduce. So let's take a quick look at how automation is used today across this process. So we do already rely on automation on software to do that detection that a problem or a fault has occurred, and ideally to automatically create that ticket for a service desk, network operations, security operations, and so on to do the investigation. And note that with fault detection, we're not logging in every few seconds to check logs, diagnostic outputs. We rely fully on our software systems and network management protocols to do this work for us. We rely on those APIs to auto-generate tickets based on monitored alarms and so forth. But when it comes to the bulk of the actual work, that diagnostic investigation, this is commonly still very manual, CLI-driven, sequential device by device. And then when it comes to the remediation, the fix, had tools for a while that can push out configurations successfully and quickly. But when it comes to that incident response, more automation is still necessary. The automation of the before and after benchmarks, those quality assurance tasks, to know that our change caused no additional harm. And of course, verifying that our change actually fixed the original problem as intended. So for today's talk, we're really focusing on this red area here, this diagnostic investigation part of the workflow. And stepping back to the big picture view, how can we apply automation, a full automation strategy to incident response? And where does triggered automation fall within that process? So here's a high-level framework of the application of just such a strategy, applying automation at every stage of the incident response workflow. You can think of this as a journey of a ticket through its life cycle with the stops along the way, and each stop is improved with automation. So working backwards, starting with the conclusion of that incident, we look to leverage proactive automation concepts and using those lessons learned to feed back into an automation process earlier on. And of course, during the active investigation, during the collaboration, and during the remediation phases themselves, let's make automation available interactively, on demand, empowering teams to really pull in a lot of stuff quickly all at once and to perform rapid analysis rather than the typical sequential manual methods of diagnosis. And of course, today's focus is on this area here of the incident response with the concept that we want to discuss further, triggered automation, automating that initial diagnostic investigation. So I'll note here that we'll be exploring further these areas of interactive and proactive automation in future webinars. So with the triggered automation, what we're concerned with is a couple of things: applying automation to that initial response to an IT problem, and with automating the retrieval of useful, contextual, comprehensive data the moment an IT event starts. When it comes to the manual methods of that diagnostic investigation, especially this critical initial investigation, we do face several challenges. So first, I'd say is the non-standardized nature of that response. So this means that we're going to have varying degrees of success, unpredictable results, ultimately depending on the expertise or experience of that first responding engineer. Next, we have the common problem of ticket idle time. So potentially you have a ticket sitting in a queue for an hour, 2 hours, maybe more, waiting for someone to begin that investigation. We know that NetOps teams and IT operations teams are flooded with tickets and events every day. So while the problem resolution here is delayed, potentially valuable data can even clear before being collected. And of course, all of this is very time consuming. right? You get building that end-to-end path just to stitch together the list of devices and interfaces and things to look at. It can be a very lengthy proposition. So we end up with a need for more staff to handle what should be a relatively small percentage of engineers' time. NetOps, as you know, already has plenty to do besides incident and problem investigation. So of course, eating up countless hours for all of these initial incident and IT problem investigations is far from ideal. And of course, this impacts our MTTR KPIs as well. Those repeated issues can cause just as much time to investigate every single time they happen, without something to feed into the initial response process to offset that result, to improve or auto-identify common issues. Also, we have problems with collaboration. We have varying degrees of collected and recorded notes, diagnostics, retrieved data to be handed off to the next engineer or team should the first engineer need to escalate that investigation. This lack of automation in organizing this diagnosis means, again here, that we have ultimately inconsistent results. And what does all this mean? So all of this results in an increased MTTR for problem resolutions. So what do we want to accomplish with triggered first response? What's needed to solve this first response problem with automation? So we desire to automate best first response. And what do we mean by best? So here we're talking about that standardization that I referenced earlier, ensuring a consistent, predictable result, predictable every time, make this repeatable. So picture this as taking that best practice response to let's say a slow network event. You take the best engineer on your team, whatever those set of checks, diagnostics, and things that were done, let's package that up and reuse that every time, right? So that's the goal of a standardized response. And the other part of that is have it be comprehensive, right? Don't miss a check or a diagnostic, especially in an incident where things can be stressful. You've got this predefined, comprehensive a checklist of what you want to look at, right? Networks are simply too complex to rely on intuition, gut feeling, and we really need to be guided by data and data analysis. And of course, automate time-consuming tasks. I mean, this is the reason for automation in general. Speed up everything. So it's those 100 or more CLI commands that you may have had to run to do this initial investigation. Have the system auto run those at the time of the event detection. Have all those outputs ready for me when I show up at the ticket. So this is the goal here. And software is designed to accelerate the work of humans and to do it in a multi-threaded rather than a sequential manner. And lastly, we want to drop that first response time to 0. So this allows us to meet your ticket SLAs every time, eliminate that ticket idle time, capture that hard to catch data for intermittent issues, ensure an automatic first response every time. So this is one of the big values out of triggered response. So here, let's step back and take a look at what does an engineer need to do. So with or without automation, all reported network problems are always going to need these 3 fundamental data gathering and analysis tasks to be performed when investigating literally any network problem, right? So the first thing, and this is always a very time-consuming thing in complex environments, is isolate that problem area. Define where and what I need to investigate. So this is that end-to-end network path and associated things affecting packet delivery. In other words, get the list of all the network nodes, switches, routers, firewalls, load balancers. Get those ingress and egress interfaces. This is something that you might be getting into each device, running 5, 6 or more commands to understand where that packet is forwarding to the next, layer 3, layer 2, and so on. So you get that full path built. This is something we all have to do. And then once we know what to look at, we have to look at it, right? We have to do that initial triage, that basic data gathering, verify the fundamental network health. So this is going to involve some basic checks as well as some slightly more advanced checks, typically done via CLI. So you're going to want to know, are my network nodes healthy for monitored resources, CPU, memory, and then the network interfaces. Are they dropping any packets or any other packet forwarding problems, errors, buffer, MTU things? And then we have a need to do that very basic ascertain that the design's in place, right? And I don't mean like a deep dive into the design, but just, hey, do I have my BGP peering up as expected for my high availability pair of firewalls are both still standing up? So these are all things that we're going to do as an initial set of data gathering, just to verify the environment for literally any problem. And then, of course, we all do this. It's those basic analytics. So, I come in on a Monday morning, there's some service not working. I know it worked maybe over the weekend or Friday. First thing I always ask is, well, what's different? Who did something over the weekend, or what changed, right? So it's one thing to be able to maybe compare, do a config diff on like my core switch against the last backup. But what about baseline parameters? So maybe my MAC address table on one of my switches is double the size, and it wasn't before this problem. Is that related? Who knows, right? But maybe having these things highlighted would be helpful. So I have to do this basic analytics, usually with a series of dashboards and kind of intuition-driven thing in the manual kind of means of doing this. But these are the three things we're all going to do for every problem. So now let's look at how NetBrain's platform and the technologies it employs for first response automation helps us with those three areas. So of course, it all starts with that fault detection in your various IT tools. NetBrain's philosophy is that no incident ticket should be touched by a human before automation has first done its job. And the way we do this, NetBrain provides a very robust API framework. So we have north-southbound APIs. We're designed to really work within your given workflow. So here we start with an example of an API triggered event from a third-party tool. It can be a monitoring tool, an ITSM, a log, or a SIM tool. And of course, once we get notification of that event and scrape the parameter, source, destination, and so on information out of that event, we can then automate that diagnosis. That same thing your engineers would be doing. So NetBrain automates the diagnosis by doing the same tasks I showed in the previous slide, by accessing that data directly from the infrastructure itself, just as an engineer would do, except doing this with automation, doing this at scale, doing this multi-threaded, doing the work of hours in literally seconds. And we enable triggered automation to do these two things, to capture the crime scene, as we say, for every IT incident, automating that map. This defines the scope of the issue and isolates the infrastructure that we need to look at. And then, of course, NetBrain does that initial investigation, capturing those critical diagnostics using our executable runbook technology, pulling in multi-vendor, multi-technology data, even data from third-party tools, and comparing it all against our recorded baselines. So now let's walk through these three things I mentioned previously in a little more detail and show what NetBrain does for all of these initial response activities. So the first thing is that mapping of the end-to-end path. Again, that first thing every engineer would do is, hey, log into that first layer 3 hop from the setting host and try to see from there, hey, where am I routed? What's my full path here? So NetBrain does all this in real time, and it's a true hop-by-hop, accurate and real-time packet forwarding path. It's not trace route. It's literally checking the same series of operations that you would check to determine how that packet is being forwarded. So it does those same 3 or 4 or 5 commands you would do on each network device, router, switch, firewall, load balancer to determine this accurate path. This automatically defines the area that we want to look at for the application or service that's impacted. And of course, with this end-to-end path, we have the host involved and everything in between. We also have the full list of network nodes that need to be checked, and the same thing for every ingress and egress network interface, device by device. So these are the interfaces that I mentioned that we'll want to verify against errors, packet loss, congestion, other data forwarding failures. So the second piece is that diagnostic data collection. Here we desire to drop the first response time to 0, to retrieve and organize and analyze real-time data at the moment of the event itself. So here NetBrain implements a predefined best practice response. You can see here on the screenshot, we're actually automating 6 different tasks, but each task can be many CLI commands. And again, each task can be many CLI commands against many devices, right? So these are a comprehensive set of checks. This is what enables a customized, comprehensive, automated first response, one that can be continually tuned as new best practice findings are determined. And lastly, we need to run through that essential and initial analysis of what's different today, right now, while this problem is happening, that was not there before when everything was working well, when everything was healthy. And importantly, what's not normal? So like I said, it's one thing to be able to do config diffs and look at configurations versus maybe the previous backup to understand if something was as a result of some change. But what about these other values and aspects of your environment that you might not think to check? Like I noted, maybe your switch MAC address table is twice the size. So this is normally a mix of intuition and a collection of dashboards and other metrics to determine what may be amiss. Why do I have a route table 4 times the normal size? Is that relevant to what's happening now? What other things are in violation of previous baselines that I might not think to check in the midst of this stressful incident investigation? So NetBrain, with its golden baseline functionality, is able to track and baseline thousands of variables, right? Things you would not necessarily think to check, and reveal those on the map automatically. So I think this is a good place to go over to Chris Lopez and jump into our lab environment to take a look at all this firsthand. So let's go over to you, Chris.
Thanks, Chris. I'll share in just a second. So hey, everyone. I'm going to be walking us through what this looks like in a live environment. I hope you guys can all see my screen properly. So here we're inside of our instance of SolarWinds. I've purposefully created a problem in my lab environment that SolarWinds was meant to pick up, which it did about 20 minutes ago for a slow video application. Within 30 seconds of it detecting this severe alert, it was able to generate an incident number. It was actually able to contact ServiceNow and generate a brand new ticket for the incident, using sensor information that came from my monitoring system, which in this case is SolarWinds. Inside of the ticket that SolarWinds automatically created, we can see that it's pulled some sensor data directly into some related fields, like a source IP and a destination IP. In addition, it's also using this information to tell NetBrain to create a map of this area. And this is the first thing that Chris was talking about, which was isolating a problem area at the time of the ticket. In addition, because a machine is responding to this eliminates the problem with your with the tickets sitting idle shortly after they're created. But in this instance, ServiceNow was given appropriate information to give NetBrain to create a map, which it then put the link back inside of the ticket for, giving me the ability to see the isolated problem area and also have a basic diagnosis executed on top of it. So the diagnostic data gathering is done here on the left side with this runbook. We can see the results of several commands are executed across all these devices, and we need to reference them. And we also have another data view template down here, which is looking for common indicators of performance issues like input errors and output errors and CPU and memory utilization. This map inside of NetBrain represents everything that exists between the video server and the video client. Effectively, it's the critical path, and these are all the devices that you need to be focused on when you're trying to troubleshoot this area. In addition, we're able to determine whether or not something is out of order because of something called the golden baseline. It's a machine learned basically NetBrain takes about 7 configuration backups on your devices and generates an understanding of what healthy network traffic is. And whenever you run a data view template or some other kind of automated data view template, not just for overall health checks, but also for other different types of tasks you can use with data view templates, then it's going to compare the results to the one that it got inside of the golden baseline. And if it's off by a specific margin, it'll alert you. It'll give you a time-lapse graph of everything that's occurring on your network, and it's going to possibly give you some recommended actions that you can then continue to follow. Really helping there the amount of time that it takes to run a basic diagnosis, the amount of time it takes to figure out where the problem is, and just how difficult collaboration becomes when you're when you're not using a shared point of reference like this. Now it's not just for this one instance. We actually have another instance here. The ticket here was created with ServiceNow, but the ticket here was created with BMC Remedy. We had a similar instance inside of our lab. We basically created a DOS attack against one of our servers, and Splunk picked it up, and then Splunk fed information directly into BMC Remedy, which it then used to send an API called NetBrain, which it used to generate this map, which I have up here. So here, again, we can see a problem area has been isolated. We see the attacker who's come from an unknown subnet here is at every device that it hits along the way to the web server. And we also have a diagnostic runbook that's been executed, which has the overall health check, but also looks at maybe third-party data from Splunk or ServiceNow, or maybe we have PRTG, and we want to pull in all that sensor data in the context of all these devices. All of this is made available on this map. This is, you know, your user interface, and this is and this is the way you interact with the environment. And that in that way, it's going to save users a lot of time when they're dealing with new network incidents. All right, that's everything I had on my end. I'm going to pass this back to Chris, and he'll be able to keep us going.
All right, thanks, Chris. So let's look again now at the full solution. So this, as you saw in Chris's demonstration, NetBrain's triggered automation can be initiated by any third-party system to which we are integrated via API. This can be monitoring systems, ITSMs, SIMs like Splunk or Tufin, other IT management tools. We've got a lot of pre-built, just as a side note, we've got a lot of pre-built API code for a lot of these products already available on our GitHub. And literally anything that has a documented API, though, we can build an integration for. So this is something to keep in mind. So again, these IT systems kick off the incident response process that we outlined earlier. And of course, specific to trigger automation, again, what we provide are those benefits we discussed, namely capturing the crime scene, defining and isolating that problem area. And secondly, at this stage, we capture valuable diagnostics for that initial best first response. And again, just to reiterify, we auto-identify those baseline violations to enable us to know, is what I'm seeing, is this normal during my investigation? So let's now take a look at what I've found really to be the ultimate implementation of a triggered automation concept, and that's NetBrain's app for ServiceNow. So this is an application that we developed for ServiceNow integration. It's downloadable on the ServiceNow App Store, and it enables NetBrain automation functionality embedded directly into every ServiceNow IT ticket. So this makes it exceedingly easy for existing ServiceNow and NetBrain customers to apply automation to existing IT operational workflows. Provides a great overview of the diagnostic automation concepts that I've discussed. So triggered automation integration here with ServiceNow gives us the ability to, again, auto capture that crime scene, that problem area of the network for every IT incident, and enrich that ticket with a dynamic map. So again, we'll show this here in a moment in another a brief demonstration, but this is embedded directly into the ticket. So this enables us to automate that best first response diagnosis. So again, known problem diagnosis. This is another thing that can be a common issue. So you've seen this problem, you go through some steps to resolve, you get to the resolution. Well, now when that problem comes up again or a similar variation, you know, do I need to go through the same lengthy initial investigation every time, right? So this app enables us to automate a best first response for these well-known problems. Additionally, we can add further contextual data related to the same area of the infrastructure that can be linked and automatically populated within the ticket. So in this example here, we know there's been some QoS design involved in this area of the network. So we've set it to automatically pop up here in the ticket as relevant information. And we can even include data from recent changes, such as a recent network upgrade, to auto-populate as relevant information to be available in this ticket. So this is all at the moment of that event. But the moment the event reaches, the ITSM reaches ServiceNow, ServiceNow communicates to NetBrain via the ServiceNow app, grabs all this stuff, puts it directly into the ticket here. So this is a little glimpse of that functionality you can see here in ServiceNow with that embedded functionality directly in the ticket. So that's the real benefit here, is that it is embedded nature of this automation and diagnostic automation functionality, putting NetBrain's dynamic map, putting NetBrain's automated diagnostics directly into the ServiceNow ticket, enabling any IT engineer that has access to ServiceNow, even those say outside of the network team, to leverage the value of NetBrain's automation and that visibility. So hey, let's go back over to Chris. He's going to get into our lab once again and run through a demonstration of this ServiceNow app functionality and show us how it applies to the triggered automation strategy that we've been discussing. So over to you, Chris.
All right, thanks. And we're going to see the inside of a new ticket of ServiceNow. So for those of you who said that your first indicator of a new problem is a ticket, here's something that's especially you are going to want to take a look at. So over here we can see that the NetBrain ServiceNow application is going to provide some similar functionality to what you've just seen. I'm going to identify a business service that's being impacted. I'm going to go identify a configuration item that's associated with this incident, and I'm also going to provide a short description, like the IP of the of the user that's coming in, and the nature of the issue, like video slowness. And I'm going to go ahead and submit this. There's nothing here right now, but in just a second, we're going to see that NetBrain is going to be kicked into gear, so to speak, given the information that you inputted in these fields here. So down here with NetBrain Automation, you can see two maps, much like the ones Chris was showing you. So we have an application slowness crime scene map, and this is very similar to the ones that you saw before. It's based off of the laptop IP of the user and the business service that's being impacted. And with that, NetBrain is drawing an A to B path of everything that exists between those two devices. Only this time it's not just within NetBrain, it's actually embedded inside of ServiceNow, really helping the collaboration factor, because anyone who has access to ServiceNow is going to be able to have access to this, to this problem area. And also some limited automation capabilities on top of it. So here I'd be able to execute my basic overall health check on top of this device. And then down here, we have a known problem map, which is based off of the configuration item that I specified up here. So essentially, ServiceNow is going to start combing different maps within NetBrain for that specific configuration item. And it's going to return with any problems or any prior maps that we had in this folder that relates to other incidents that we've had on this segment. So in this instance, we can see that we had a faulty transceiver on SF Core demo, and now this map is being brought back to our attention when a new incident is being called up, because SF Core demo is part of the voice platform. So it's giving me a really good indicator of where I need to check out next, and also just things I should probably rule out off the bat. So in this sense, you can see how NetBrain is not only providing you, the ability to isolate the problem area and gather diagnostics, but it's also giving everyone the ability to do that. By making it available not just within NetBrain, but as an embedded map inside of ServiceNow. And that's why I have the show. I'm going to pass this back to Chris, and he's going to wrap up for us here.
All right, so let's go ahead and wrap up here. So in summary, the application of NetBrain's triggered automation within your automation strategy for IT operations, this provides a range of benefits. And keep in mind that that's what we're looking at here, right? This is an automation strategy for IT operations that we're looking to leverage here. So one of the biggest value here is that you're going to meet all of your ticket SLAs. So that ticket that hits your queue, you're going to eliminate that idle time. You're going to instantly begin that investigation. So that ticket has been touched right away with these automated diagnostics and automated contextual network and data visualization. All of this captured in real time. All of this relevant to the problem at hand. And of course, we get to utilize, what we're referring to as that best first response for every event that hits your team, ensuring that it's standardized, customized, best practice, initial diagnosis every single time. And of course, ultimately, all of our goals is to reduce that MTTR. Even if you can have a goal of, hey, by the end of this year, we desire to reduce MTTR by 10%, that can be a very lofty goal, right? So it's something we all strive for. So triggered automation here, it eliminates that gap between detection of an event and the act of investigating. It ensures, or by ensuring rather, a consistent, comprehensive first response for network operations the moment a problem is detected, and automating that diagnosis and those data analytics all of our problem resolution times are greatly improved. So that's really the role of NetBrain automation. It acts as essentially like the connective glue for your workflow, for your various data sources, be it the low-level data sources coming from the devices themselves, or the higher-level data sources, coming from those data processing tools, your NetFlow analyzers, and all these other kind of analytic tools that we use within network operations. The automation strategy kind of sits in the middle of all this. So that's all I have for today. That wraps up our presentation and our demos. I do hope that you found this session informative. Hey, thanks again.